Hi everyone, I'm Hannah. I'm a tutor at Sky Academy, and in this video we're going to be talking about measurement. But there's two topics within measurement. There's MSM6 and MSM7, and in this video we're going to be looking at non-right angled trigonometry, which is MSM6. Ironically, to start though, we're going to be talking about right angled trigonometry, which is just revision and a foundation for non-right angled trigonometry. So hopefully you have all heard of Socatoa, which is just a helpful way of remembering the three formulas here, 1, 2, and 3. And it is where the S stands for sine, and it is opposite over hypotenuse. The C stands for cos, which is adjacent over hypotenuse, and T stands for tan, which is opposite over adjacent. So these three formulas here, 1, 2, and 3, are the formulas that we use within Socatoa. But memorizing these three formulas by itself can be a bit tricky. So if you just pop it all together in Socatoa, it's a bit easier to remember. Now, if we look here, we have a right angled triangle with the labels on each side. So this side here is our hypotenuse, this one here is our opposite, and this one here is our adjacent. However, in your exam question or an exam at school, you will not be given your triangle with labels on it. You will have to know how to distinguish which side goes with which label. So there's two ways I like to know which label goes to which side, and that's two landmarks. We're going to use a right angle, and we're going to use a marked angle or theta. So the side that is opposite our right angle is going to be our hypotenuse, and the side which is opposite our marked angle is going to be simply the opposite side. And the side that is left without a label is going to be our adjacent. So that's a quick and easy way to remember which labels go with which. You just remember the two landmarks, your right angle and your marked angle. And the opposite, the right angle is going to be hypotenuse, and opposite our marked angle is going to be our opposite. And the leftover one is going to be our adjacent. So now we know the three formulas for sine, cos, and tan, and we know how to label our right angle triangle. We're going to have a look at an example. So here we have to find an unknown side in a right angled triangle. So we have to find the length of x in the triangle shown, answer correct to 3 decimal places. So the first thing that I'm going to do in my right angle triangle is I'm going to label which side goes with which label. So here, opposite my right angle is going to be our hypotenuse, and opposite my marked angle is going to be my opposite. And I know the leftover side without a label is going to be my adjacent. So now I've got those labels on each side of my triangle, I need to figure out what labels I'm going to use. Because if you have a look here, sine only uses two sides. It uses the opposite and the hypotenuse. It doesn't use the adjacent. So in a triangle of 3 sides, I need to figure out which 2 to use. So I know that I'm going to use my side that is marked with a value, and the side that is unmarked with a value, but the side that I need to find. So this side here, my adjacent, is marked with a value of 20, and this side here, my opposite, has no value, but it's the side that I need to find. So my hypotenuse contributes nothing to my answer, which I'm trying to find. So I'm not going to use the hypotenuse in the question. I'm just going to use my adjacent with a value of 20 and my opposite with a value of x in my equation. So now I know what each side of my triangle is, and I know what 2 sides I'm going to use. I can go ahead and answer the question now. So I know that opposite and adjacent is going to equal tan. Tan here is the only one with opposite and adjacent in its little formula. So, sine is opposite and hypotenuse, and cos is adjacent and hypotenuse. And so tan is the only one with opposite and adjacent. So I'm going to use tan theta equals opposite over adjacent. And now that I know my formula, I'm going to sub in these values from my triangle into the formula. So tan theta is actually going to equal tan 35. So I'm going to pop 35 in there, in brackets, and my opposite is going to be my x, and my adjacent is going to be my 20. Now I've got this, I can solve for x. So I'm going to do simple algebra, and I'm going to take my 20 over the other side of my equation, and I'm going to times it by tan 35. So tan 35 times by 20 is going to equal x. And when you pop that in your calculator, you should get a value of x equals 14.004 to 3 decimal places. And that's my whole answer for this question. However, you do have to be aware that some questions will have a value such as centimeters next to a marked side with the values on it. And so if this question had 20 centimeters here, my answer would also have to be in centimeters. But because the 20 has no value associated to it, I don't have to worry about putting a value onto my answer. So that's how you find an unknown side. In our next question, we're going to look at finding unknown angle when given values on a right angled triangle. So firstly, once again, what I'm going to do is I'm going to label each side of my right angled triangle. So the one that I know opposite my right angle is going to be my hypotenuse, and the one opposite my marked angle of theta is going to be opposite, and the side with no label left is going to be adjacent. Now I've got my 3 labeled sides, I need to figure out what 2 I'm going to use. And because we're trying to find an angle this time, I have to use 2 sides with values on them. I'm not going to use a side I'm trying to find, because I'm not trying to find a side, I'm trying to find an angle. So I'm going to use my one that is my hypotenuse with 8 meters, and the one that is my opposite with 5 meters. So I'm using my hypotenuse and my opposite, and then I'm going to go to my Socatoa, and I'm going to figure out what value that is, tan, cos, or sine. And hypotenuse and opposite is going to be sine. Sine is the only one with opposite and hypotenuse, because cos has adjacent and hypotenuse, and tan is opposite and adjacent. So those two, cos and tan, don't work, but sine does work. So I'm going to use sine. So sine theta is going to equal my opposite over my hypotenuse. And now I'm going to sub the information from my triangle into this equation. And I'm trying to find theta. So theta is going to stay as theta. We don't have an angle to put in there. We're trying to find the angle. So sine theta is going to equal 5 over 8. But you can't just put this into your calculator like that, because we're trying to find an angle. You have to press shift sign to come up with a -1, and then you can put your fraction into your calculator. So you can do shift sign to make it sine -1, 5 over 8. Some of you, your school might teach you to do this, sine theta equals 5/8, and then press shift sign and put your answer into shift sign. But I find it easier just to do it all in one go, shift sign 5/8. And when you press equals, you should get an answer of 38.68. But we know in our question, we have been asked to find it to the nearest minute. So to find our answer to the nearest minute, you have to press what I call the bubble button. It's the button under the fact, and it has 4 little bubble things on it. So it's that one there. And I'm going to press that bubble button, and it's going to transform my answer into degrees, minutes, and hours. And so I have now 38 degrees and 41 minutes, because I have to round up. If it's 55 seconds here, I have to round up because 55 is over halfway. Halfway seconds is 30. So it's above 30, you round up to 41. And that will be my answer for finding an angle of a right angled triangle. It's much the same. You still use Socatoa. You still label your triangle sides with hypotenuse, opposite, or adjacent. But when you're solving for your angle, you just have to remember to press shift sign or shift tan or shift cos or whatever it is, because it's an angle and not a side. You're going from 2 sides to an angle, so you have to include the shift button in your working out. So now let's have a look at a real life example. These examples are really common in tests. They might use a boat out on water, and there's a cliff, and then the boat's down here, and that's how they get their triangle. That's a really common one. But in this question, we have a statue which casts a shadow 12.6 meters long, and the sun rays from the top of the statue to the ground make an angle of 43 degrees. What is the height of the statue? So this question has not been drawn for us, so we have to draw the diagram according to the words. So I'm going to quickly go ahead and do that. So I know I have a statue here, and I know that it casts a shadow 12.6 meters long. So if you imagine yourself standing out on the road and the sun hits you and causes a shadow, your shadow is flat on the ground. And so that's why I drew my shadow straight across the ground. And then the sun rays from the top of the statue to the ground makes an angle of 43 degrees. So I'm going to go and label my diagram. This is going to be my statue. This is going to be my shadow, which is 12.6 meters long. And the sun rays is going to be my hypotenuse. And it's going to make an angle with the ground of 43 degrees. Now I've got all the information on my triangle. I'm going to label each side. So I know the side opposite my right angle is going to be my hypotenuse. I know the side opposite my marked angle is going to be my opposite. And I know the leftover side without a label is going to be my adjacent. Now I need to figure out what 2 sides I'm going to use in my question. So I'm going to use the side that I need to find. So I need to find the height of the statue. So I'm going to use my opposite, which is my S, my statue. And I'm going to use my marked side with a value. So the side with a value is my adjacent, which is 12.6. And those are the 2 sides I'm going to use in my answer. So now I can go ahead and do that. I have my opposite. Oh, we're in yellow. Let's change to black. Here we are. I have my opposite and my adjacent. And I know my opposite and adjacent is going to equal tan. Because once again, if we have a look here, the only one with opposite and adjacent is our tan. I know tan equals opposite over adjacent. And once I've got this equation, I can go ahead and I can sub in the information from my triangle into my equation. So tan theta. Tan theta is 43. Tan 43 equals opposite, which is my S, the side I'm trying to find, over 12.6. And then I can do my algebra step and take 12.6 across to the other side of the equation and times it by tan 43. So tan 43 times 12.6 is going to equal S, and S is therefore going to equal 11.7. So that's how you figure out the values of either a missing side or a missing angle when given right-angled triangle with Socatoa. Pretty simple, you just follow Socatoa. Sine equals opposite hypotenuse, cos equals adjacent over hypotenuse, and tan equals opposite over adjacent. And the only trick is to remember in finding an angle, you have to press shift sine or shift tan or shift cos because you're going from a side to an angle.